when the session will be ended, you can ask our GDE to answer that questions. So first of all, hello everyone. Welcome to our day 9 of our machine learning study jam. Today we are diving into exciting topic of augmenting LLM prompts for contextual clarity, building a RAG system using open source technologies. As we all know, the ability to provide contextually rich and precise prompt is crucial in leveraging the full potential of LLM. We are incredibly fortunate to have today with us Ashmi Banerjee, a Google developer expert in machine learning. Ashmi is currently a doctoral researcher at the chair of connected mobility at the Technical University of Munich. Her impressive achievements include being named one of the 100 technologies to watch for 2023 and winning the prestigious GDE Community Award in 2023. Ashmi brings a wealth of knowledge and experience to our session, and we are thrilled to have her insights share with us on building retrieval augmented generation system using open source technologies. Um, we'd be loving to have her knowledge being shared with us. Over to you, Ashmi.
Thank you so much. I see some questions in the chat and one person raising their hand. Should we take that now, or a lot of people are raising hands? I don't know why.
Everyone is suggested to please type their questions if anyone's got any query in the chat box. Ashmi will just continue with her session. That'll be more preferable. And if you want to answer any questions, Ashmi, you can do it at the end of the session.
Okay, sounds good.
Yeah.
Okay, then I'll start by sharing my screen. So thank you so much, Kanat, for the lovely introduction. And let me maybe present them. Okay, you should be seeing my screen now. Yes. Okay, cool. So today, as Kanat mentioned, I will be discussing about RAGs and how to basically improve your LLM prompts by adding some more context in there. And we will also see how to build a RAG using open source technologies. So a little about me. I'm a PhD candidate at TU Munich, and I have been working on tourism recommender systems. Previously, I was a data scientist at Deutsche Telekom, which is the German telecom. And I also did my master's from TU Munich, and I'm a ML developer, Google developer expert, and a Women Tech Makers ambassador. Talking about the RAG, so we will start with a little bit of like LLMs, what they are. I mean, I will not go into too much detail because at this time I feel like most of you know what LLMs are. We will discuss a little bit about the different strategies of how to get the LLMs answer some contextual queries. One of them being fine-tuning, the other one being RAG. We will talk a little bit about the different RAG overview and its architecture, the pros and cons. Finally, we'll see a demo, and if you want, we can also walk through a Colab depending on the interest and the interest and time of the session. I mean, I have it prepared, so yeah, depending on whether you would like me to do that. Cool. So LLMs, they are basically transformer-based models that process and generate text. I mean, you know, at this point, I guess ChatGPT, Bar, Gemini, Gemma, a lot of different models are out there which are basically pre-trained for some general purposes. But if you want them to answer some very specific questions or very specific domain, then you can fine-tune them to that specific area. They are trained, obviously, as the name suggests, large language models. They are trained on massive amounts of data, and hence the large part, and a lot of different parameters, like, I don't know, several billion parameters using self and semi-supervised learning techniques. So, but then the problem is that what if we need to extract some very precise information from the LLMs when we want them to be very specific? So there are two more. How do we solve that? There are two main methods. One is to fine-tune the model with some specific data. Say, for example, you have you want a model to answer specific questions specific to a domain. For example, You have like a model which will ask you for medical questions or legal questions. So in that case, you fine tune it with legal or medical data to answer these things. Or the second option is to use retrieval augmented generation or RAG, which we will learn in a second what that is. So for the first method, or LLMs, fine-tuning LLMs, what we do is we take the LLM and we try to train it on task-specific data. So, or domain-specific data. As I mentioned, that if you have like a data set on legal or medical or specific task, like, okay, it has to do this specific thing, then you train it on this specific data set. And what you do is you update the weights of the LLM and then you observe the loss. And once the loss converges, you stop training. And this whole process, however, is very, very computationally expensive. So some numbers, maybe, for example, if you would like to train like a simple 7 billion model, you would need at least, so there's like a rough estimation formula where you need like number of parameters times 2, so 2 bytes per parameters, which is like 7 times 2, 14 times 4, so one parameter for the parameters, one for gradients, two for the optimizer states, plus maybe some batch size for activations, and that amount of, at least that amount of GPU memory for training the whole model. And if you want to run like more batch size, then obviously more memory is needed. The minimal requirement, like using this formula or like this estimation for a 7 billion model will be like around at least, I mean, one or two NVIDIA A100s with 80 gigs of RAM. And that would result in a cost of like at least 26,000. So 26,000 USD. It's not cheap. And then 13 billion would not even fit on a single A100. So you would need more, multiple A100 or even H100, which is faster or more expensive, like 30 to 40,000 USD. So basically, it's very, very expensive. That's why researchers developed another model where they call it like parameter efficient fine tuning, where they only fine tune certain layers or certain weights. So what they do is they use something called adapters, and imagine this to be something like your adapter for the socket. So say, for example, if you're traveling from Pakistan to UK or US, your Pakistan sockets, like the cable adapters, will not work, right? So then you need an adapter which you can connect it, and then you can connect the other side to the US or your UK plug. So think of it something like that. So use like a low rank matrix, which is one of the ways of doing it, to as an adapter to the LLMs, and then you compute the loss. And this significantly reduces the computational costs. So, but overall, this process has some pros and cons. So this requires first of all, a lot of domain-specific label data in the form of instructions. So it has to be very, very specific and at least 10,000 rows, which is not always possible to get. And therefore, also, since you are like kind of retraining the model is more prone to hallucinations, and it might just give out answers that it doesn't know, but it just like makes up. And it can get tricky, particularly in case of domains such as legal or medical, where obviously if it gives wrong answers, then it's extremely detrimental to this extremely detrimental to the society. It often works as a black box, so we don't know how it will work. I mean, you're just doing, and it's kind of like a black box, and it's also not very scalable, and it can be very, very expensive. That's why who comes to our rescue? It's retrieval augmented generation, or RAG. So RAG is basically like an open book test for the model where it is supplied with some additional text context to find the relevant answers. You do not, the LLM is frozen. You do not fine tune it, or you do not do any kind of like experiments on the LLM itself. So use like a pre-trained model, and then you supply it with additional context, and then you basically try to get the answers from it. So it's a kind of a form of in-context learning. Typically, it uses like an external vector database that stores this relevant data, and then you pull out the data, relevant data from this database. And it's great for like fact-driven applications or when the data keeps changing. For example, if you ask the LLM who won the World Cup last year, it might answer something like it might answer wrong, and you can also try to try to talk to it to answer it wrong. But then if you have some like list of facts provided to it, then there are the chances of it answering wrong is or hallucinating is severely reduced. So let's look at a naive RAG architecture, how it looks like. So we have the first stage, which is the retrieval stage, where we have a bunch of documents. In this case, I'll be using the Wikivoyage data abstracts, which is publicly available on HuggingFace for 160 EU cities. And we will pass it to an embedding model. Embedding model is nothing, but it just converts the text into some numbers or vector space. And these vectors are then stored in a vector database. In this case, it's a MongoDB atlas. Next, what happens is we send the user query, which is basically your prompt. It could be something like, okay, tell me what to do in France. And then you embed it using the same model. You get the embeddings. One thing to make sure here is that you use the same embedding model that you used for getting your vector database results, as well as the embedding for the user query, because otherwise it will not match as good. Mm, and then you do a comparison, like a similarity. So you can use cosine similarity to calculate the different matchings or how close they are to the existing context. And then you get retrieve the top K most similar documents. That becomes your context. Once you have the context, what you do is you append the context to your existing query to get your final prompt. And once you have the final prompt, you you feed it to the LLM. In this case, we are going to use schema, and then you get the final model response. So basically, it's just adding some more context to the prompt before feeding it to the LLM. That's the very naive architecture of RAG. So the pros and cons of this process is that it's often possible to trace back the model's response. So why the model is behaving in a way that it is behaving, and why it is not behaving in the way that it's supposed to behave, and it's easy to debug these things. So it's like higher transparency and accountability. And it's also very easy to scale because obviously you just have to improve the quality of your data, and that's all. And then it's also very less expensive. You just need like to pay for your storage, data storage, which is much cheaper than paying like 26,000 at least USD for GPU. Right. On the other hand, the problem is that it often pulls out different like relevant information, but it cannot nuance the specialized instances. For example, if you are talking about specific domains like legal or medical, they have a certain technique to write. So the medical people have a certain technique in a way they write the stuff. So obviously, if like since it in this case the LLM is kind of still the pre-trained model, and it does not have any like it hasn't learned or adapted to the techniques of like how to write the information, it might not be well suited for certain tasks, right? Because it can give you factually correct answer, but then these nuanced ways of how to write these things might not be already might not be adaptable. And it's also a bit more complex setup, and it doesn't work for like direct inferences. So we kind of, since you are appending more context, so you would need a lot more like context windows. So you need like big models with like bigger context windows. So for example, Gemini 2 million or something like that. So time for the demo. This is the link to the demo and the code. If you want, you can scan it and see. Let's see. So as you can see that we built a very, or maybe I can show it. Um, so we built it on HuggingFace. You can also scan the link and yeah, and then you see that it is, we selected the model as Gemma, and yeah, and then you get the results, and you ask it to, maybe it's not super visible in this video, but you ask it some questions about like recommending European cities, and then you select the model, and then you get the results. Yeah, if it works, I can try to show you. So yeah, if there's interest, I can walk you through the code, interest and time, but otherwise I would say thank you very much. And yeah, thanks for your time. And these are all the references and resources that I used. And if you want, you can also provide some feedback for the talk, whether you liked it or not. And yeah, thank you very much. So
All right.
should we, yes,
Yeah, we can take questions if you want.
sure.
If anyone's got any question, they can open their mic and ask Ashmi directly.
Yes, ma'am. Can you hear me?
Yes.
So I want to ask. So we are facing in this era where like technologies are upcoming in our head. So how can I stay updated with these research papers? Like I just studied RAG and advanced RAG and modular RAG. So how can I stay updated with these type of things?
I mean, there's no one size fit all answer to it, right? And it also depends on your motivation, your areas of interest, and your how you would like to do that. I mean, the idea would be to just have a look at the papers that are being published at the top conferences and seeing like what they're publishing and see where your interests lie, and then reading the relevant papers and their references. So there's no like hard and fast rule that this is the way you can do it.
Yes, I'm building a RAG application, and
Mhm.
I'm a generative AI engineer. And also, I want to ask, how can I study more technologies that is upcoming in the RAG term, or they're like the modular RAG, advanced RAG, or I'm studying a LangChain platform, but I want a more something.
I mean, it depends again on the, I would say focus on your problem instead of first focusing on the methodology. That's my way of approaching things. So what I can recommend you is to focus on the problem that you have in hand and then try to answer that problem. And if it requires RAG, great. If it doesn't require RAG, if it requires something else, then go for that. I mean, but depends on the problem. I would say it's kind of a vague question at this point. I don't have enough data points to answer this basically. Okay, any other questions?
I think we have a question in our chat box that is by Furkan Malik. Can you explain a bit more about adapters?
Mm-hmm. Yes, so adapters are basically like low. So in case of this particular algorithm, LoRa or low rank adaptation, what happens is that they use some low rank adaptation matrices because ultimately everything is matrix, right? So if you have the matrix and you have a low rank matrix, so then you multiply the bigger matrix with the low ranked one, and then finally you get the answer. So it's like a lot less If you have the weights of the original thing and you have some low rank weights, and then you multiply them, and then this low rank matrix acts as like an adapter. So yeah.
Okay, one last question we have from Shahir Abdullah. We are
Mhm.
not updating the weights of models. Is there any method to evaluate RAG?
Yes, we are not. The LLM is frozen here. We are not making anything, making any changes to the LLM weights. There are ways to evaluate the RAG. So, for example, you can evaluate the different prompt statements or the prompt templates that you use. You can get your answers. I mean, the best way of evaluation would be to see like how the RAG is behaving through a human evaluation. So basically manually. The other way, like if you want more automated, like some ideas could be to use like a bigger LLM to evaluate the questions and the answers and see whether how it works. But there's no, again, one size fit all evaluation strategy for that.
Okay, we have Hamza Nader who wants to ask a question.
Sure.
So, yeah, you can open your mic and ask.
Hello, ma'am. Firstly, thank you so much for your time. I hope you're doing great. Ma'am, I'm a student of data science, and I just wanted to know how important is it for a data science student to get into Gen AI or these technologies? Is it necessary for me to get involved in this?
No. Long story short, no. Only get involved if you are interested in it. There are other aspects also. I mean, Gen AI is the hype that has been around for the past couple of years, but before that, data scientists did great even before, even without Gen AI. So if you're not genuinely interested in this area, there's no point getting involved in it. There are other areas to contribute as well as a data scientist. I mean, the role of the data scientist will not be compromised, at least in the next few years, or by few, I mean, at least personally, I feel like at least 10 years, if not longer, because data is the new oil. So I guess, yeah,
Thank you so much, ma'am. Thank you.
you're welcome. Okay,
Okay, I had also one personal question. I would like to
sure.
know, as you are a Google Developer expert, so I would like to know what's the procedure and what sort of knowledge or portfolio or anything you would like to guide more about that in the machine learning criteria, particularly.
Yeah, so to become a GDE, you have to have like contributions in the particular area. So like they have different categories like ML, Gen AI, I think Android, and some other web, Flutter, blah blah, like some 7, 8 different categories. And what is required is that you have at least uh, 1 or 2 years of experience. I forgot, like you have to check the official guidelines regarding the numbers, but some years of experience in that particular category, and you should demonstrate your community activities by either like speaking, content generation, like blogs, etc., um, and also some and or mentoring. And yeah, but mainly like content creation and mentoring are the two aspects.
Thank you so much. And I would like to still ask if anyone's got any questions, they can ask Ashmi about it.
I mean, if you want, I can also share this other thing. So you can just go through the Colab yourself. So here is the Colab notebook. You can go through it yourself. And if you have questions, you can reach out. So yeah.
Thank
Yes,
you,
but
Ashmi.
it's a
Actually,
bit
someone was
more.
asking for these slides.
Yes, the slides will be available on my website. So I can share it with you afterwards.
Right. And I think there was someone who was asking about which technologies are necessary to learn before it.
Sorry, can you come again, please?
Someone was asking for the LLM roadmap. What are the technologies to learn before it?
I mean, there's no specific technology. Again, I would say don't go for like, okay, I'm gonna focus on this and learn this technology. Focus on your problem in hand and then see what technologies you can use to solve that. So I think that that would be the wiser way to go.
Okay, so thank you so much, Ashmi, for your time. As
You're
we wrap
welcome.
up our day 9 of our machine learning study jam, I would like to extend a heartfelt thank you to Ashmi for sharing her
Thank you.
invaluable expertise with us today. And thank you, everyone who participated today. Your enthusiasm and engagement made these sessions more truly special. Remember, the journey of learning and applying machine learning is continuous, and the knowledge we gain is just the beginning. So we look forward to seeing you all in our next session. Until then, please keep exploring and experiment and keep pushing the boundaries for learning. And have a great day. Thank you so much, everyone. See you next time.
Thank you. Bye.
Bye.